I'm not huge on planning. I try to find what is the minimal amount of planning that I can do to find out the stupid mistakes that I would make in day one and day two. I think a lot of the times, if you can plan and you can see around corners and you have a straightforward project, then plan away. But I think a lot of the times, a trap that I see people fall into is they go into this completely new project that no one has ever built before, complete innovative solution of something, and they try and plan it ahead. And it's like, dude, you know nothing about this.
Are you a scaling SaaS founder? Ready to make the leap from leading a team to leading an organization? Join us each week as we refill your think tank with actionable tips and strategies from great business minds you know and those who don't know yet. This is SaaS Fuel with your host, 5-time entrepreneur, SaaS founder, and globetrotting adventurer, Jeff Maines.
Welcome back to the SaaS Fuel podcast, where balancing features and tech debt is like trying to renovate the kitchen while still cooking dinner for a party of 10. Anybody felt that way? Oh my gosh, our dev team absolutely does all the time. I'm your host, Jeff Maines. I help B2B SaaS founders like you grow from traction to scale. Here, growth is more than just numbers. It's about crafting a future-proof company, premium valuation, and leaders who build a business of significance while living epic, adventurous lives. What if speeding up your release cycle was the key to better quality and not the enemy of it? In this episode, we challenge a common assumption in product development that moving slower means fewer mistakes. Instead, we're going to explore how accelerating delivery with the right systems in place can actually improve product quality, reduce backlogs, and make your team a whole lot happier in the process. We'll dive into the shift from a feature-centric mindset to a more balanced approach, one that values not only new functionality, but also defect resolution, tech investment, and smart risk management. You'll hear how cross-functional collaboration breaks down silos, allowing teams to move from idea to execution with fewer handoffs and far less friction, which everybody appreciates. You'll also be introduced to mental models that reshape how teams think about their workflows, tools for optimizing backlog, managing work in progress, and creating space for continuous improvement. And instead of chasing perfection through delay, this episode advocates for frequent, high quality releases that build team momentum and customer value at the same time. If you're a product leader, engineer, or founder looking to ship smarter and build a team culture that thrives on progress, not perfection, this episode is your blueprint for making it happen. Let's get into it. Our founder on Tuesday was Alberto Rizzoli, CEO of V7, which is one of Europe's fastest scaling AI companies. Pretty cool. Alberto pulled back the curtain on what's next for human-machine collaboration. We explored how AI agents are transforming productivity, why companies need chiefs of AI to truly benefit from these tools, and what the shift from tool to teammate really means for the modern workplace. Our expert guest last week was Michelle Griffin, founder of Griffin Resources. She showed us how to grow operationally without bloated retainers or outdated org charts. From fractional hiring to succession planning, Michelle broke down how startups can scale their support systems with flexibility and without breaking their budgets. If you missed either episode, go back and check those two out. My guest today, maybe straight from the Avengers, is Thanos Diacakis, a seasoned software leader who's helped startups and tech giants like Uber deliver better products faster. With 25 years of experience across the entire stack, front end, back end, mobile, infrastructure, firmware, all of it, Thanos knows how to scale engineering teams without the burnout. He's the rare builder who sees both the code and the company, translating technical decisions into real business outcomes. From leading the Jump Bikes platform integration at Uber to streamlining delivery and scaling ventures, Thanos is on a mission to eliminate cargo cult rituals and revive velocity where it matters most. Welcome to SaaS Fuel.
It's great to be here. Thanks for having me on, Jeff.
You've scaled software systems at both startups and giants like Uber. Now, what led you to focus so deeply on streamlining software delivery and helping teams move faster without burning out?
Well, I had to do it. And then I found
love
out that whenever we were doing it, it always was terrible. So I started off with, there's got to be a better way to do that. And I did that at my first job. And then I did that at my second job. And then at some point you start noticing the patterns. It's like, wow, this is terrible all across the board. And that's what led me in the past several years to be doing just this, as opposed to going and working for someone and building software for them.
But it's more than just like checklists or, for delivery or, what is it that really makes software delivery work well and streamlining it, beyond some of the basics?
Yeah, as a pilot, I love checklists, but they're not the right thing for software, right? It's the right thing when you have to make sure that your plane has all the right bits attached to it before you go. But I think for software, it's a bit more complicated. I would say there's 30 or 40 capabilities that a team must have to be effective in putting software out the door. And most teams that I work with have like half, and it's never the same half. So it's not that you go to this team and everyone is missing CI/CD. No, some people will have very advanced systems in one area and be completely lacking systems in a different area. So what I typically do is I try to get people to think about software a little bit differently. There's some things that are counterintuitive, and I've kind of built some sort of ways of thinking about it. I call them mental models of how to do software, and kind of walk people through those. And that usually gives you some principles, and then you can apply these sort of principles in different ways depending on what your situation is, and diagnose what is happening with your particular team and how to fix it. And these, by the way, these are not just process or technology. These, I think, span culture, they span the technology and architecture and what you're actually building, and also process as well. So you have to make changes across a wide set of items to get that efficiency that you're looking for. Really,
really smart. Explain to me a little bit more about the mental models.
Yeah, so one of the things that happens is when you have a problem and you're looking for a solution, the intuitive solutions for me are the ones that the first thing comes out of your mind, right? So,
sure.
For example, you find some bugs and you say, well, we got to slow the release down because then we will be able to have more time to do testing. And that way we'll fix more bugs and we'll have less bugs. That's sort of the intuitive solution, where you kind of made a quick connection and you went from problem to solution. I think a lot of the times the solutions are become unintuitive. That's where you have to sort of apply a bit more thinking to it and use a bit more experience to find out where the problem didn't have an obvious solution, right? It's not like I can just quickly see what happens from A to B. And just to expand on this example, one of the things that would happen is if you slow down how you ship to production, is you'll have bigger batches. And bigger batches, which means you might ship more bugs all at once and have to find them in a bigger QA cycle. And when you now find a new bug, you can't just pop it back into production. You have to now wait for another big batch that has concealing more bugs. And here the solution is a bit counterintuitive. You have to go fast to achieve better quality, because then you can fix your bugs faster. And then that requires that you have certain investments in infrastructure, because we're not talking about YOLO. We're not talking about just shipping anything to production and cross our fingers and things are going to be okay. So that's kind of one of the examples, is one of the mental models that I give out is this example of speed versus quality. It's not like a speed versus quality. Don't think of it as competing, but this is the way you can use the one to get the other.
I like that. And you're right. Those are some of I would say the riskiest releases is when it's a giant release. When you have so many things in there, and if you have bugs, then, even if you've taken time and tried to ship slow, just the bigger it is, the more stuff you're releasing, just the more variables there are.
Exactly. That's exactly right. And you see this time after time. So it's like one very common problem that teams will have. So I try to get the teams to think differently about all these sorts of things. Another common area that is problematic is the interface between engineering and the business or the product side, whatever you call it in your team. Usually those two groups don't have the right words to talk to each other, and they often sort of talk past each other. So you see the very common featureitis, right? Where product only thinks about features and they just keep hammering that into engineers. And engineers, they know better, right? They know they have bugs to fix. They know they have investments to make. They know they have other risks they need to deal with, like upgrading their libraries and things they need to do. But in some teams, this gets hammered so hard that features is the only thing the business cares about. They sort of forget about this. And that loses the ability to communicate that to the business. There's no way to say, hey, we have something, we call it technical debt, we call it investments, we call it risk. And oftentimes they have to beg to get time to fix something and pause in the busy work of doing features to go fix something fairly critical that really could speed them up. They could be delivering twice the features. By the way, I don't exaggerate when I say twice the features. Sometimes you see how much time a team spends in fixing bugs, And if you're able to just invest a little bit to cut down the number of bugs, so say if you're spending like 80% of your time just underwater fixing bugs and 20% of your time building features, if you're able to take that that 80% bugs and make it 70, now you're 50% faster in features because you just freed up a bunch of time.
Right.
So that's one of the other examples of mental models that I try to get those teams to use the right words and communicate to each other and figure out what are the things that engineering does and how to negotiate these over time and depending on the maturity of the product and so on.
How should we think about optimizing development cycles for technical debt? Because we all have it. We all know that there's things that we need to do. That's not the fun stuff. It's not the sexy new features that we want to ship, but it's required. So we have to have some sort of time for that, as well as having, we do need to ship features. And so we've got lots of things in the backlog. How do you think about prioritizing one or the other, or how do you split that time in a way that's efficient?
Yeah, I start backwards, right? So we start with the idea that the goal of a engineering group or a product group, if you look at it a bit broader, is to ship value to their customers. And this is achieved by when you put something in production, you release a new version of the app, update the website, that's when value is realized, right? When it's in the hand of customers. And then I start from that and kind of work backwards from there. What do we need to do not to maximize the value that we ship this week, but in the long run? So I want the team to start thinking about how do we deliver value day in, day out, week in, week out for years over years, not just how we do it this week. That then starts having them think about what are the different activities that we need to do to achieve that. And that's where the having product understand what engineering does is key, right? I referenced the flow framework, which has 4 categories of work: is features, defects, investments, and risk. And if we all understand sort of what these terms mean, right? Hopefully it's fairly obvious. Like features is features, bugs is features that weren't working correctly. Investments is anything that makes us go faster. And then risk is anything that could be catastrophic to the business, right? So if you don't update your dependabots and some library gets outdated and someone hacks you, that could be existential to the business. And then if you begin to have these words to talk to each other, you can start having interesting conversations. Hey, we spent a lot of time in the feature bucket the last few weeks because we had this important release. Now we will have to spend the next couple of weeks a little bit on the bug bucket. And then a little bit after that, we'll have to go and sharpen our tools a little bit and spend a bit more time on the investments bucket. And maybe we have to do a whole week on risks. So maybe if we spread risks a little bit and we update our libraries every week rather than doing this once a year, it would make life a little bit easier, right? So just becoming aware that these are things that happen, I think these conversations can start to be happening more intelligently across the org. And usually what I find is that teams are pretty aligned. No one just wants to ship today and not be able to ship tomorrow. Everyone does want to ship for the long term. They're just missing some key words of how to communicate that and how to negotiate that. And there's also some rules of thumb, right? If you have a fairly mature product and fairly mature in a fairly mature company, you might be spending 30% on features and 30% on bugs and 30% on investments and 10% on risk. That wouldn't be an outrageous situation to be in. Now, I will argue that 30% you're spending on features, you're getting a lot out of it because you're staying on top of things and you're really firing on all cylinders, as opposed to someone that's spending all their time on it, but their infra is so terrible, they're really getting no velocity out of it. That said, if you have a startup and you're just started off and you're doing something completely new, it wouldn't be outrageous to be spending 80% of your time on features and then 20% of your time on sort of platform and investments, and you may not have much risk yet because there's nothing to protect. And again, be cognizant of that, right? That changes over time. So it's something you got to keep looking at and saying, what worked yesterday doesn't necessarily work today. So we adjust, and sometimes we find out, it wasn't what we thought it would be, and we just change our minds.
That's really, really good. I just love the language around that, because it's not just we've got to go fix stuff or we've got to, technical debt. And that's not anything somebody wants to do. But investment, that is such a great term. Risk. Why do we need to go take care of and retire this technical debt? Because it introduces risk. And at some point now, that makes it a much more palatable prospect. Good use of resources if we're going to go and we're going to mitigate risk by making these changes or these upgrades. Very, very different way to think about it.
Yeah, I believe so. And that's where having the words to communicate this becomes very important, right? Because if I come to you and say, hey, I need to spend 2 weeks that I can't deliver any features for you to go clean up this stuff, You might look at me a bit funny and be like, no, go work on the next feature.
Exactly.
Whereas if I come back to you and say, look, I need to invest in these systems, and when I do so, I can be spending 10% less time every week fixing bugs, which can go against features. And then also these features that you had asked me, I can build those so much faster because now I've got the right infrastructure to do that there. You don't need to go full technical on someone and just, go nuts and explain how your refactoring will have much better function signatures across your code base and increase code coverage by 3%, because no one cares. But if you can explain the business outcome that you're going to get in some reasonably straightforward terms of what you're going to do, I think that usually finds people that they connect and get together and do that.
Right, because we're talking about outcomes now. We're not talking about tasks or jobs to be done.
Exactly.
Yeah, nobody cares about that. They just we want to ship product and we want to create great experiences for clients, and we need to know that if we don't do this work, that's going to get in the way and interrupt the process.
Yeah, and these investments, by the way, that you make, they pay back for themselves in spades. So I have this this customer that I've been working with for a few years, and when we started, they had like a couple of engineers and very little by way of platform investments or anything of that nature. And it was really hard to get code out the door. They'd get like maybe one major feature in every few weeks or a month or something like that. Right. So then we worked over the last year or so doing little improvements week on week. It wasn't that we stopped doing features. They actually continued to grow and get clients all the time, and they needed new features to get new clients. But if you do a 2% improvement every week, I believe after 6 months, you're like 86% bigger. And then after a year, you're like 200% better. So small improvements will add up. And, now like a year and a half or 2 years later, this client now has 4 engineers and they're just firing all cylinders, and each engineer is shipping several major features every week. So the gains are just there to be had. And companies that just do the work as opposed to doing the work and looking at how they do the work are getting left behind. If your competition is not only doing the work, but improving on how they do the work, they're going to overtake you really soon if you're just simply just executing.
So good. What do we do with those backlogs? I think everybody listening will definitely say, I've got a backlog that never gets any shorter. It just gets longer. What do we do with that?
Throw away the backlogs. I'm being half serious. So one of the other mental models that I have is work in process. And the idea is that if work enters your system at some point in time, and you can consider the backlog to be the entry to that system, or you can consider something a bit further inwards when you pick that item up to be the entry to the system. But having work in progress, work in process in your system isn't free. It's what manufacturing calls inventory, right? It's expensive. Right. It sits around, it gets lost, it gets stolen, it goes rusty. And that's the same thing with work that has entered your software engineering value stream that hasn't been completed. That just is cruft. Let's take an example, right? You have a sprint and you put 10 items in your sprint, and you start all 10 of them, but you ship 2 of them. And then the next week, you put the remaining 8 back in the sprint. Actually, 2 of them we don't need anymore because we changed our mind. So that work is now thrown out completely. And you put 2 more in there. And now you repeat this process. Now what happens is the person working on one of the things you're going to throw out, which you don't know yet, will go and ask a question of the person that's working on one of the things you're going to keep. And they're going to interrupt them from something they're going to ship to work on something you're not going to ship, right? So that's a priority inversion where you had some time that was productive that's being stolen away from someone that was doing something you didn't know you're not going to use yet. So my general point here is that this is a very sort of evil time thief that will just take away time from you. So visualize your work in process, visualize the work in your system, and often teams are overloaded, and bringing the work that goes in the system down will actually increase the work that goes out the door. So to say it in different words is if you focus on what you're shipping, not on what you're starting. Right? It is important to get things out the door, not to start things. It doesn't matter if everyone's in a little hamster wheel running around doing stuff if what's coming out the door isn't sufficient. So in that sense, like, working further backwards from that, I advise teams not to really keep really big backlogs. Just keep a small board that has like the next few things that you're working on. Keep maybe the backlog, the things that are coming a bit after that. Don't track P5 bugs. You're never going to get to it. So just admit defeat in the beginning and just leave that out of your backlog, because otherwise you're going to have to go groom it and clean it up and look at it and decide again you're not going to get to it and decide again you're not going to get to it. So my advice for teams is focus on shipping and work backwards from there. Again, that's the same pattern. I I think for the past, 4 or 5 years, I don't think I've had any backlog that has more than 10 or 15 items in it. I usually say someone comes up with a good idea. It's like, you can put it in the backlog, or you got to take something out. It's like, well, let's put it in just in case we forget. And it's like, if it's important, you're not going to forget. Don't worry, it's going to come back. If it's that important that no one ever remembers, or a customer doesn't bring it up, it probably wasn't important enough in the first place.
Right. And how do we use our customers to help prioritize what goes in the backlog versus making strategic choices of things that we want to do, or things that we feel that we need to have to stay competitive?
Yeah, I think at the end of the day, the customer is what matters, right? So I think that drives that conversation, because we got to do, and we have a vision, right? So we're not going to blindly do what the customer says, but we're going to be inform our product vision to meet the customer needs. So when I say we're subservient to the customer, I mean, we're going to listen and try and serve their needs, as opposed to serve our internal engineering and technology plans. So I would say, take the customer input. By the way, engage engineering in that. If engineers listen firsthand to what is happening to the customers, bring them into some meetings, they can be like, oh, wait, you guys didn't ever bring this thing up. That was really useful. We can fix this in 2 days. And it seems like a really big pain point for them, right? So you engage the engineers in those meetings, you get the input from the customers, combine it with your vision, and then you got to have that creative tension between product and engineering, right? You got to think about, okay, what could we do? What investments do we want to make? That's kind of the most common trade-off we want to do. What investments do we need to make the delivery of these features be feasible? Delivering features today is one of the goals that a product group should have, but the ability to deliver features tomorrow is also an ability they should have. We don't want to just take the features that we were asked of us and just hack them in, and then tomorrow we have to rebuild it all to build the next feature, right? So having that optionality, the ability to build new things in there, plays in that decision making, and we have to consider that when picking what investments we have to make, right? I can build this feature the easy way, I can build it the harder way, I can also over-engineer it and make it in a way that and now it's super flexible for all future changes likely never to happen. So that part is the part where, we have good practices, right? It's a good practice to listen to your customers rather than not. And it's a good practice to have a creative tension between product engineering to come to the best trade-offs between new features and investments. But there's still kind of a little bit of, an art that you have to pay attention to it and kind of keep recycling and going through and looking at where your problems are. And as you fix one thing, your bottleneck shifts somewhere else and you got to fix the next thing, and so on and so on.
Oh, that's really, really good. I think that's freeing for a lot of devs, and just how we think about managing projects and just juggling all the things that they have to do.
Yeah,
so I think
you also gave me another idea
freedom
for backlogs that we can talk about. You asked about backlogs, and usually when someone says backlogs, your mind goes to features, but there's other backlogs, right? We have bugs in the backlogs. And one of the things that I have my customers look at and say, what is your input rate to your bug list versus your output rate to your bug list, right? Because if your bugs in are way bigger than your bugs out, you got a big problem you have to fix. Yeah. And usually no one has bugs going out getting fixed faster than bugs going in. So they usually will have a stable or a growing bug list. If it's growing, you got to fix it. But now if it's stable, that means you're fixing it at the same rate that they're going in and out. Well, how many bugs do you have there? Do you have 10 or 1,000? And if they're going in and out at the same rate, which one would you rather have, 10 or 1,000? Yeah. So the advice there is look at that, because if you can maybe do a little bit of investment, you can bring your big bug list to a small bug list. If you have equilibrium in your in and out, now you have a much more quality product. So a little bit of investment makes the customer satisfaction and the user of the product be a lot happier with it. So that's kind of another technique of keeping work in progress small.
That's really good. How do you use Kanban? And within those limits, because you have work in progress, you don't want to have too many things in the backlog, you don't have too many things in process. How are you thinking about that as it's flowing through the system?
That will depend a little bit on your team structure. So when you do Kanban, depending on how many people your team has, and if you have multiple teams and they're on the same board and so on, but the most common thing is you just have a limit of the items that are in progress. You have a board, sort of the backlog that's behind it that needs to feed into what is ready to go. So let's say if you had a team and you had 5 people and maybe they're working on a team of 3 and a team of 2 kind of together. So maybe your max here is 2 things. They're kind of working on 2 projects at a time. 3, not 10, not 1, right? So that gives you kind of some idea of the size that you'd have, the main doing sort of Kanban column. And then you have to have a Kanban column behind that. You want it fed. You don't want it to ever be empty, because then people will be stranded without having anything to do.
Right.
But you also don't want to be 100 steps ahead, because if you're thinking about this project today that someone's going to do in a year, when they come ask you for info, you've forgotten all about it, and maybe it's changed, and maybe you wasted all this work. So you kind of want to keep it lean and not exactly just in time, but enough time to give you just buffers for if something goes wrong, but not like to overload or to have it too empty at any point in time.
Sure. Yeah, I think a few weeks, maybe a few months, depending on what your dev cycles are, because especially today, the world is changing so fast.
We haven't said the AI word since the beginning of this podcast.
It has to come up at some point.
I was at a conference last week, and the whole thing was about AI. I kind of think you could go for 5 minutes without hearing about AI.
Yeah.
It's completely a whole new world. It's a lot of fun.
Yeah, we had some things on our dev board for a couple of years, and it's like we'll get to these projects and really kind of thinking big, and then it's like we don't really need that anymore, because we can implement this in AI, and it's going to solve 2 of these, and we don't even have to build it, because it can just be done. And it's amazing just how quickly technology is changing, and just kind of rethinking the way we build software and what we need, and what things become obsolete because they can be automated.
I have knocked out all my personal coding projects over the past 6 months. Like pretty much everything that I had that was like, yeah, I'll get to this someday, they're all done.
That's
so
cool.
much fun.
Are you missing key relationships that could transform your leadership? Most leaders are. They just can't see it. And here's what shocked me. The most successful leaders aren't lone heroes. They're the center of 4 specific relationships that multiply their impact while preserving their sanity. You're probably like everybody else, drowning in connections, but starving for real support. And it's creating a silent epidemic of leadership burnout among executives just like you. So, take my free assessment at thecaptainskeys.com. Discover which critical relationships you're missing in under 5 minutes, and then grab my new book, The Captain's Keys, part Netflix drama, part game-changing blueprint for leadership that actually sustains you. One CEO called it the owner's manual I never got. So stop flying blind and see what you're missing. Do you have any favorite tools that you're using for that?
Not really, and yes. So I currently use a tool called Rue, which is like a fork of Klein, and it's just one of those VS Code IDE add-ons that you can chat with it and play with it. I found that the tool doesn't really matter as much. I've played with Cursor and Codex and Claude and all these guys. Yeah. And I find they're fairly similar. What is important is how you guide it. And I find that the answer there is in very, very small chunks. You have to give it a thing, and then it will tell you something that's completely crazy. And you're like, okay, that's nice. Just come back over here. So they're like an intern that is more or less typing for me with a little bit of leeway to type like kind of roughly what I say, not exactly what I say. Yeah. And if you keep them controlled, you can churn out a lot of good code in a very short period of time. I've started experimenting with some of the more agentic ones where you give it a thing and they go and do something for like a few minutes and come back with an answer. And I found that they go off the rails really fast. So it's like, whoa, no, the architecture for this is no good. Like start over. So then I have to wait another 3 minutes till it comes back. And also the chunks that they give you to review are way too big. So, as much as I want to say, hey, I'm super smart and a senior engineer, I know what I'm doing. Like my brain can only hold so much. So when you give me like 1,000-line change, I can understand your 1,000-line change. So like I usually ask it and say, you may have 1,000-line change, but human is stupid. So give it to me like in 100-line chunks. Like paint me a story of what you're doing here. And then it gets pretty good because you'll say, okay, well, define my data over here. You see it, you get it, human. And I'm like, yes, I get it. Okay. And then it starts, building the function signatures and then populating the functions inside. And it's like, now I can follow it and I can get to a pretty good architecture.
That's really smart. Because you're right, the more you can do that and kind of go through the process in smaller pieces, the better the outcome is. Instead of write this giant thing 1,000 lines, and one, it would take, you're right, forever to review. But then just understanding what are all the things you're trying to pack in here without having, just like you would with another person. Walk me through the code. Tell me, what does this do? What does this do? Why did you do it that way? And so kind of step by step, it's a lot more collaborative, I think, than just go write me a bunch of stuff that maybe gets me where I want to go.
Yeah, now I'll caveat it, right? I had a personal project that I worked on last night. that I really didn't care how it was going to get written. And the architecture wasn't that important because it was going to be super complicated. It wasn't going to be super complicated, right? It was actually a fairly complicated set of tech, but it was like read stuff from here, output over there, and that's as complicated as it's going to get. So I switched over to Codex in agent mode, and I said, knock yourself out. And actually, that was pretty efficient. Like, the code was okay. It was not the best, but it was appropriate for the job. And I got it done pretty quick, and it would have taken me a lot longer to go step by step. And again, you can use this for some things where you have like a really tightly defined problem. Maybe if you have unit tests and you're refactoring inside something where the results can be super tightly controlled, you can kind of lean on those tools. And I think those tools, by the way, they're going to get better. So yes. we're talking today, end of 2025. Like if you're listening to this like a year from now, the answer is like the agentic tools may be working like 1,000 times better, and knock yourself out using those. So it's a very rapidly changing environment. So advice here is experiment, because these things are getting better and better.
It's amazing. We're 1,000 times ahead today from where we were a year ago. I mean, it's unbelievable how fast it is going and getting better. And I can't imagine what it'll be like,
especially with smaller teams, right? With small teams where the bottleneck was actually typing in the code, it's now like tremendously faster. Bigger teams still have different bottlenecks because they still have to, the PM has to talk to the EM, and then they have to get consensus as to how they're going to build this. So it wasn't necessarily the bottleneck in this process was having the engineer just type in the code. It's definitely going to have some improvements there as well. But I think when you're in a bigger team, when you're past the 2, 3, 4 people, you still have to do good engineering across the board and not just hope that the AI is going to magically make things better.
That's true. Good engineering and planning is so important. Understanding what the approach is and what the outcome is, and being on the same page with other people, so you're not all building things in your own way.
Yeah, but can I get controversial on planning?
Please.
I'm not huge on planning. I try to find what is the minimal amount of planning that I can do to find out the stupid mistakes that I would make in day 1 and day 2. I think a lot of the times, if you can plan and you can see around corners and you have a straightforward project, then plan away. But I think a lot of the times, a trap that I see people fall into is they go into this completely new project that no one has ever built before, complete innovative solution of something, and they try and plan it ahead. And say, dude, you know nothing about this. This is like an experiment. So like plan a little bit to make sure you're going to get some basic parameters going, but then go do. So I have a bit of a bias to action and starting and doing it, and then kind of adjusting the plans as need go. I don't want this to be interpreted as, you have carte blanche to go into stupid stuff and because things that you could have totally predicted. But I also think we sometimes convince ourselves that we know more than we actually do, and that we can plan a really long way out. And we make these plans and they fall apart within like a week or two, and then we pretend we're following them, and then we go spend a lot of time planning again. So it's like plan enough, but just enough to get you going, and evaluate what benefit you're getting from your planning, and repeat.
Like that. A lot of the learning does come from doing. And you'll learn so much more by just executing and figuring out what works and what doesn't, especially if it's new. You haven't done this before. Yeah. You get out there and try and see what's working.
And let's face it, most software is new, right? Because if the software already existed, we go buy it rather than build it. I think we've mostly
unless you
learned
ask
that
a developer, should we buy or build?
Right.
I've done that too many times. But you're right. Yeah, if it's something that is out there already, a lot of times we either have something that we can use as a pattern, or just buy it or acquire it, or find an open source or whatever it may be. But a lot of times you're right. It is something that's completely new. It's not something that we've seen done before, and we're trying to figure out how to build it in the best way. But we just don't know what the best way is because we haven't done it.
Yeah, and software has many degrees of freedom. Everyone, at some point, if you work at a big company, you start getting if this was a building analogy, which is always fun. And if you ask me how to build a bathroom, there's only so many combinations you can arrange a sink, a toilet, and a shower in so many arrangements, right? You can have 1 or 2 of each or whatever, but there's so many possibilities, and there's like so many kinds of flooring and so many kinds of tiling. So there's a fairly finite way of doing this. Whereas with software, there is a gazillion ways. Like you can pick thousands of technologies, different programming languages, architectures, and you can organize your software in so many ways that there is that stability that you'd have, that predictability that you have of building a bathroom. Like, the bathroom could take from like a week to like 5 months is a really fancy bathroom, but you're not going to take 10 years to build a bathroom, right? Whereas the software, depending on what you're doing, it could like the results could be like literally anything. So it's a lot of fun figuring out what that is, and what is your rough estimate, and doing all these exercises people try to do.
When we're doing that, because there is so much freedom, how do we align priorities? And especially when we're talking about business needs, technical limitations, those two things are somewhat in tension.
Yeah, have you seen that? There's a little meme that works its way around every now and then that has the incremental development, and on the top it has like a wheel, and then an axle with a wheel, and then it has the platform of a car, and then eventually it has like fenders, and then eventually has the top of the car, and then it drives away. And it contrasts that with having a skateboard, then a scooter, then a bicycle, then a motorcycle, then a car, right? And the idea there is generate incremental value. Don't start with, when you're thinking about priorities, if you engage engineers and product in these creative discussions, you might find out, I scoped out like these 10 things, but it turns out the customer gets 80% of the value from this one thing. And then when you talk to the engineers, you might also find out that of that one thing, 90% of it is really fast to build, but the other one is really, really hard. So if we made these trade-offs in this way, we could deliver customer value much sooner, much faster. I think these discussions and these quick iterations enable you to incrementally build this customer value, set priorities, see them as you go. So my preference is to build a team that can deliver functionality in days, maybe weeks, not months or quarters or years, so that you can start delivering these really thin slices. The elephant carpaccio is another gruesome way to think about it, perhaps. But these really thin slices that add value. So not only do you see value early on, so you can start realizing some of the gains earlier rather than having to wait a long time, but also the really important thing is they help you steer. So if you're like making 4 releases a year, you get 4 opportunities in a year to steer the ship. If you're making every week, now you have 52 opportunities to steer the ship. And if you're making releases every day, you have a lot more opportunities to steer the ship. And I think that helps you get to the destination, because sometimes we think we want to go over there, but it turns out we really want to go 50 degrees to the right, and we won't figure this out if we don't change the plan. It would be a lot easier to get to it if we make small incremental corrections rather than have to wait for the end to get to it.
Yeah. I can't imagine a company surviving if they're only shipping every quarter, because things just go too fast. You need a lot more opportunities to steer the ship. And maybe that's not as true if it's a giant enterprise, but I don't know, maybe it is. Maybe that's why they're not as agile.
I don't think I've ever worked at a bank, but I imagine that that's maybe how some banks work.
That's probably true. What are a few common practices when you're talking about teams and working together that maybe those practices look good on paper, but they don't really work in reality and maybe even harm delivery?
Yeah, I think we talked about planning. So file that as under one thing, right? I tend to start with the practice. So teams usually have trouble figuring out how to get started and what to do, because they will try and find and fix bottlenecks in wherever they kind of feel them. But it's not necessarily fixing bottlenecks that will sort of fix their output. So they end up, just to give you an example, so to bring this back, you asked the question about practices. So that's kind of a long way of getting there. They try to optimize locally for one particular function rather than optimize globally for shipping things out the door. So as I run through an example of how you very commonly see this, especially in bigger companies. So you have maybe, this is kind of an example that has many steps of the way. You can imagine it's with fewer steps, but maybe you have like some research department that figures out this is a new feature that customers want, hands it over to product that figures out exactly what they would like, how they'd like this to work. Maybe it goes over to design and they kind of build some screens, then they hand it over to engineers. They go build this thing, then they go test, they ship it over to testing, they test it, and then it goes to operations that ship it. Now, again, you could have a very straightforward model. Instead of having these 7 steps, you could have like product, engineering, and operations, or even just product engineering. But what happens is, this is kind of a pipeline model, right? If you have 7 steps, by the time something comes out the right end of the pipeline, there's 7 more things in the pipeline that have entered from the left-hand side. And these kind of mechanisms help because they make everyone efficient. Well, the designer always has work on their plate. The tester always has something to test. The engineer always has something to build. Right. But imagine now what happens when something comes out the right-hand side and it's not correct, right? Now we have to grab this one little block, and come and kind of insert it in this machine somewhere in the middle, where the person that needs to pick it up, has forgotten all about it because it's probably like several weeks away from having worked on it originally. And now these gaps start appearing in the pipeline, because now if I have to work on this, then the other thing I was working on now is to wait for a little bit. So gaps appear in the pipeline as it continues. And it gets worse and worse, right? Because some other things are going to start flying backwards, and we end up with a lot of inefficiency. So these kind of practices, like the writing a spec and sort of throwing it over the wall, and having someone kind of work off some specification and then hand over to the next person, is one of the worst things that I see happening. And it optimizes for people being busy, but doesn't optimize for shipping things out the door. And the recommendation there, just to not have people hanging, is get people that are cross-specialty in the same room, virtual or otherwise, and have them collaborate from the beginning to the end, right? So instead of having this pipeline where everyone just ships it, writes it, and ships it over to the next person, put them all in a room. They all collaborate. This is not as efficient, right? Because the designer will be like heavy up front, but then they'll have little to do at the end. However, when the engineer needs to ask a question about the designer's right there. They can answer that question. They can tweak a design if something is needed or if something didn't show up as it was needed. So what that does is really compresses the time that we need to go from idea to production. Now, that, I'll argue, is the most important time, because once you get in production, it's value realized, and that's how the business makes cash, as opposed to having the designer be busy. Now, again, once you get really good at that, you can then start looking at how to do some efficiency improvements. But that's like a common, really easy way to get started, is like just destroy these pipelines and start just getting everyone that you need to make a decision to ship a given feature, product, project, whatever it is, in the room at the same time.
I think there's a lot less ambiguity in that as well, and just the questions that come up, and you surface issues a lot faster, and that they're dealt with on the front end, and you have less defects on the back end because you have a lot more collaboration.
It's called the principle of locality, right? Where you keep everything close together. And it can be like physical proximity. It can be temporal proximity. If you have people that build in the same area of the product, stay together, so they have more context as to what they're doing. It shows itself up in many places where you get a lot of efficiency gains by bringing things close by they're related.
You definitely would have efficiencies in that. Probably less defects as well. And just because you really have that you're shipping value, it's not just shipping features or shipping the thing that was on the board, the next project. You're actually doing something that really does have value across the board, and everybody understands why.
And we've talked about deficiencies and value to the customer, but one thing we haven't talked about that I think is super important is happiness.
Yeah.
And there's two ways that this shows up in the models that we've been talking about. One is if you have too much work in the system and people are getting jerked around, trying to do this, do that, that is not conducive to people's happiness. People don't like constant change and constant shuffling. This is not to say we shouldn't be agile, that if priorities change, we can't jump and do something different. But if you're constantly firefighting, that is not a sort of a happy environment for someone to be focused and doing their best work. So by applying all these principles that we've talked about, I think that increases engineering happiness. The other things that engineers like is shipping stuff. They like seeing their products and what they built being used by the end users and realizing that value. You didn't hear anyone saying, hey, my product got filed away and archived. Yay, it's done. You hear people, hey, we took this thing and it went from this many users to that many users. We shipped that much thing. That's what gets people excited. So by applying these things and going from idea to production in a short period of time, you also much more increase the satisfaction of everyone in the team, not just engineers. I think everyone feels happier when their work is out the door. And when you have happy people, you have good work, and you have this like virtuous cycle and flywheel of improvements that starts happening, as opposed to the environment where everyone's cranky and it's like, this is changing again. Oh, you want to work on this? Oh, there's an outage. Oh, there's a bug I'm going to go fix.
Yeah, that's rough. You can really burn the team out quickly. In your experience, what are the signs that a team is maybe running too hot, and what levers do you pull to restore sustainable speed without compromising output?
By the time you get to that, output is already compromised. It's obvious to everyone, right? Because you ask engineers what you're... Yeah, I mean...
That's good.
Because everyone is looking at it and going like, we spent the whole of yesterday dealing with this outage and there's like 100 bugs in the queue. And I don't think you need many metrics. Like you go to these teams and you can just feel it. You could literally stick your head over the office and everyone is just looking angry. and sad. These situations are very obvious. And I think, unfortunately, the state of the industry is one where this is much more common than we would like it to be. I've worked at a lot of different companies, and you see different teams that are just constantly just burned out, and people are leaving and just not happy in there. And I think that's where the mental models become powerful, because the typical solutions that teams jump into when they see these is, okay, well, they're unhappy because this was too unspecified and they had to go and talk to the product people to figure this out. So let's write tighter specifications next time, or let's leave out more time for testing, or let's get more people on this team. And the problem is you had already too much collaboration, too much noise happening, you just throw more resources at it and you think that's going to help, right? So I think that's where I find, like, taking a step back and looking at these mental models and looking at what actually helps with getting stuff out the door will get you to that solution. It's really tough, right? Because it's really tough to have a team that is stressed out and getting things out the door and say, you have to start by doing less. It's like, wait, no, I already have so many things in the pipeline. It's like, yeah, but you're not shipping them. So if you want to ship them, you have to, like, start focusing on a few things and get good at shipping them. And it's a little bit of a leap of faith. But once you start and reorganize it in a nice way, and you start shipping one thing and shipping another thing, that begins to sort of rebuild trust. Yes. So it's like, hey, I know, like, you haven't shipped anything in several months because I had thrown 100 things at you, but, like, we did this nice thing now, and we've been able to ship 3 weeks in a row of fairly small features, and I know we can sort of keep building on this. And you can see the teams that do this, they sort of rebuild the trust and they get these more productive relationships across the board to ensure sort of their long-term velocity. So sometimes that just takes a little debugging and it's fun to do.
That's good. Well, you've led teams at scale, but also worked with startups. What do elite teams do consistently that average ones don't?
There's a set of capabilities that the better teams have and adopt and find out ways how to invest in themselves. I think that's the one clear thing that you do. I was at a conference last week, and there's one of the talks that someone asked how many people have read the book Accelerate. I don't know if you're familiar with that one, but only 3 hands went up in a room that had maybe 50 or 100 people. And I was, like, taken a little bit aback. There's a lot of really good practices that are not just correlative, they're causative to having effective teams that basically everyone should follow. So I think if I would give anyone advice is, if you haven't read Accelerate, then go read that book, because it basically lays out in terms of, and this is in terms of, like, core technical and procedural sort of infrastructural things that teams ought to have to be productive. Beyond that, I advise teams to sort of be introspective, look at how they do the work, and always have some kind of experiment going on that tries to improve their work. You find a bottleneck, the bottleneck will try to, once you fix it, it will shift around and go somewhere else. So if this was what was keeping me be slow, if I fix this, now my output goes higher, and now something else is making me slow. It's usually not more than one thing. If you can imagine, like, a complex network of pipes connected together, there's usually, like, one place that controls the whole thing. You fix that, and then the bottleneck shifts somewhere else. But it's unlikely 2 things are exactly the same sort of aperture that they both constricting the flow. One model that I have when I go through teams through this, because a lot of teams just get lost. Like, okay, there's so many things going on. Where do we start? Like, what the heck do we do to get this thing under control? So I have, like, a 4-step process that I follow. That it's not the checklist, because you can move around sometimes. You can apply it in different ways. It's just kind of some guidelines of how to get started if you're not sure where to go, which is iterations, quality, complexity, and planning and predictability. Planning and predictability being one thing at the end. So the idea is start with iterations, because if you can't get software out the door in any shape or form in a quick fashion, you're not going to get anywhere, right? You can't improve quality until you can start shipping a little bit. So this has everything to do from your linters and your static typing and your CI/CD pipelines and everything that just helps you go from A to getting the code in production in some reasonable manner. So once you have that one done, now the next problem you can immediately have is quality, right? So you need to be able to test all these things and make sure that everything works. So that might mean you need to structure your code in a certain way. You may need to add some testing. Automated testing is the ideal in 2025. You should do that. So those now start to play with each other, right? If you can iterate and you can keep the quality reasonably high, you can actually start going pretty fast. And what usually will happen then with teams is their system will get more complex and more complex and more complex. And then they start feeling some pain from that. So that's where you deal with step number 3, which is complexity. By the way, this is not just system complexity. This could be cultural complexity, procedural complexity. Sure. This adds up. This shows up in a lot of places, right? We had a lot of bottlenecks. We put some systems to protect those bottlenecks. We forgot to take them off. We didn't do releases on Fridays because we needed availability of people to test that they weren't broken. 3 years later, we have automated testing. We've never broken a release, but we still done the release on Fridays. Well, we're losing shipping value one day of the week. So, that kind of craft can start going away. So paying attention to complexity is the third step. And then now once you have that, you start reaching for planning and predictability. Okay, we'd like to plan a year. We weren't able to, but now we can string several weeks together and it's looking pretty good. So now maybe we can string a month together, and we can string a month together. We can make a quarter together. Maybe even a little after that. Maybe we can have some good ideas of roadmap items going out to a year. A lot of teams try to reach for planning up front, right? And that, I think, creates a lot of mistakes because if you can't execute, but you're reaching for predictability, you're probably not going to get very far.
Right.
So I advise teams to go in order. Like if you think you're go 1 and 2 covered, then dig in number 3. But generally try to keep some semblance of order. If you're going backwards the whole time, then you're probably doing something wrong, but there's room to jump around.
That's absolute gold. And we'll make sure and link that in the show notes, as well as Accelerate. It's a fantastic book. Everybody should read it. The science of lean software and DevOps. Gene Kim. It's a few years old, but it is 100% relevant to today's environment. Maybe even more now in an AI world than ever.
Yeah,
so really good.
If you've read the Accelerate, then the DevOps handbook is also gold. And there's the Phoenix project and the Unicorn project go together. And then if you're going down that rabbit hole, you can read The Goal. There's a lot of really good books. If you
Goal
want
is
to go down
really
that
good
path.
too. Yeah. So much good stuff.
It is exciting times, my friend.
It is. Well, where can people learn more about you online?
They can check me out at my website, which is cosmicteacups.com. I have a free PDF there that outlines all the 7 mental models and a bit of details for each of them and how you can apply them to your business. And I love nerding out with folks about this. So if you if you like to chat about this, set up some time. I'd love to talk to people about how to improve their operations. It's always a lot of fun. It's my thing.
Outstanding. We'll make sure and link that in the show notes as well. Cosmic Teacups. It's a cool site. How'd you come up with that?
It's a pun on Bertrand Russell's Cosmic Teapots.
Ah.
He was imagining if you can prove that there is a teapot floating somewhere around Saturn or something like that, which I like as a principle because it just proves that we don't really know what we don't know, and it's it gets philosophical at times and try to ground it with practical things as well.
I like that. Fantastic. Well, Thanos, it has been such a great conversation. Thanks for being on SaaS Fuel.
Thanks for having me on. I enjoyed this very much.
You can learn more about Thanos and his company at cosmicteacups.com. Yep, you heard that right. cosmicteacups.com. It's a pretty cool site. As always, all links, highlights, resources, and full show notes are available at saasfuel.com. And be sure to check us out on YouTube as well. It's at Champion Leadership. Lots of resources over there for you. Thought leaders share. Share this episode with someone who's turned their calendar into a Jenga tower of back-to-back Zoom calls. Mine looks like that a lot. Everyone who shares this week gets a holographic clone that attends your meetings, nods strategically, and auto-generates follow-ups in Shakespearean prose. Bonus feature, it panics slightly less than you do. How do you lead an entire company into the future of work without losing your team along the way? Our next guest, Monica Marquez, the founder of Flipwork and workplace AI strategist, joins us to talk about what it really takes to drive AI transformation at scale. From executive mindset to frontline engagement, she's helped Fortune 500 companies rewrite the playbook and build cultures that can thrive in an AI-first world. Pretty cool. Then after that, 1 week from today, Klee Kleber will be with us. He is a partner at Build Group and marketing leader behind iconic brands like Rackspace and Dell. Klee breaks down what it really means to build patiently, invest with intention, and scale companies without chasing short-term exits. All those shiny objects along the way. This is venture without the venture drama, so don't miss that. I'll see you next time, and as always, enjoy the journey.
Full show notes for each episode, which includes a summary, key takeaways, quotes, and any resources mentioned, are available at saasfuel.com. Be sure to follow and subscribe wherever you listen to podcasts. And if you're enjoying the content and getting value from these episodes, please leave us a rating and review at ratethispodcast.com/saasfuel. We'll be sure to read these out on future episodes.
Let's go!